Hello everyone and welcome to the video. I'm Catherine with the NeoCyber Institute, and today we're going to talk about simple cryptography techniques that you can use for CTFs. CTF stands for Capture the Flag. In Capture the Flag events, you practice and learn about different cybersecurity or hacking techniques. There are many different types of cryptography challenges you could find, so in this video we'll go over 3 types that you could see: railfence, Vigenere, and RSA. We're starting with railfence ciphers. This type of cipher can seem complicated, but is very easy to encode or decode with when you understand it. Before encoding, you should set your key to a number that defines how many rows are in your fence. Suppose we are encrypting the words, "This is a railfence cipher," with a key of 4. You can see on the slide how the writing should appear. In the top left corner, the T from the plaintext appears. Each of the next letters are written in the space to the left and 1 row down until the bottom row is reached. Then the words are written going up. This pattern repeats until all the words in the plaintext are written down. If there aren't enough spaces to fill up the railfence completely, put in an X in the missing spots. These X's are called nulls. When writing out the ciphertext, you simply go from left to right, row by row, as if you were reading a book. Decoding the railfence is not difficult. There are many online decoders, one of which is linked in the description. You can also decrypt it by hand. If you know the key, it's pretty easy. First, you can draw out the pattern the words should follow, using dashes or X's in place of letters. Remember, the number of rows you should set is equal to the key. Then, going from left to right and top to bottom, simply substitute the letters in order. You can see on the slide a partially filled in decryption. The colors in the ciphertext correspond to the letters in the decoding chart, so it's easier to see how to sub in the letters. Once all the letters are substituted in, write out the letters in the order of the zigzag. That should be the plaintext. The Vigenere cipher is like a more complicated Caesar cipher. Each letter in the plaintext is encoded using a different Caesar cipher, as determined by the key. Caesar ciphers are one of the most basic ones. You simply shift the letters forwards or backwards by the amount stated in the key. So if your key was 3, A would become D, B would become E, etc. So suppose our plaintext is a Vigenere cipher, and our key is NeoCyber. Using this Vigenere square, encoding is simple. First, you find the row labeled with the plaintext letter. Next, find the column headed by the corresponding key letter. So if you're encoding the first letter in your plaintext, find the column headed by the first letter of the key. The intersection of the row and column gives you the ciphertext letter. For the first letter A, we go down to the row that starts with N and find the column for A. Our first ciphertext letter is N. Then for the next plaintext letter, V, we find the row for E, which is the second key letter. Go down to the E row and find the column for V. Our second ciphertext letter is Z. Once the letters of the key run out, start over. It's okay if at the end you haven't reached the last letter of the key. To decode, the steps are a little different. First, you want to find the row of the first letter of the key, same as when you encode. The second step is to find the letter in the row that corresponds to the ciphertext. So in our example, find row N first, then look for the letter N inside the row. Once you find the letter, trace upwards to find the column header. That's the letter in the plaintext. So for the second letter, find row E, because it's the second letter of the key, and look for the letter Z. When you find it, move directly upwards and find the column header, which is V. That's the letter in the plaintext. Of course, there are many online Vigenere decoders. RSA is a bit more complicated. First, you'll need 6 different numbers: P, Q, N, totient N, E, and D. I'll explain what these all mean. P and Q are 2 prime numbers. They're usually large and not easily guessable. You'll use them to calculate N, which is simply P times Q. N is the modulus you'll use for both the public and private keys. Next, you'll calculate the totient of N. The totient of N represents how many numbers smaller than N are coprime with it. Coprime means that the 2 numbers share a greatest common factor of 1. So for example, the totient of 10 is 4, because 1, 3, 7, and 9 are the only numbers less than 10 that have no common factors with it besides 1. You then choose a number E, such that E is between 1 and totient N, and that E and totient N are coprime. E is your public key exponent, the number that, along with N, makes up the public key. The last number to pick is D, where D satisfies the equation D times E mod N equals 1. D is your private key exponent. If you don't understand modular arithmetic, I'll include some links in the description to helpful articles explaining it. So now that you have your 6 numbers, you can create your public and private keys. The public key is N, E, and your private key is N, D. These keys are used to encrypt and decrypt your message. The public key is the encryptor and can be shared with anyone. The private key must be kept secret, and it's used to decrypt the message. The first thing you do when encrypting a message is to convert your message into a number. You could, for example, change the letters into their decimal ASCII equivalent. Your ciphertext number will be your message to the power of E modulo N. Now you can send your encrypted message to anyone, and it should be virtually impossible to decode without the private key. Decrypting the ciphertext message works pretty much the same way. You take the ciphertext number and put it into the formula on screen. It works the same as encryption. It's the ciphertext message to the power of D modulo N. To get to the original message, just convert your message number back via the opposite method you used in the beginning. So if you use the decimal ASCII equivalents to the letters, then do that in reverse. When you're doing capture the flags with RSA problems, it's usually better to write a program to solve it than to use an online decoder, but I've linked an RSA website in the description. I hope you all enjoyed this cryptography tutorial for CTFs. If you have any questions, leave them in a comment down below. Like I said, the description box has links to online decryptors and the Wikipedia articles for the techniques I talked about. This is Catherine from the NeoCyber Institute. Thanks for watching.